Good morning everyone, and as Steve said, my name is Anna and I am a marine ecologist at the Cawthron Institute. And this morning I'm going to present to you some of Cawthron's recent work on state of the environment monitoring of the Shakespeare Bay Estuary. But first I'm just going to give you a bit of background about estuaries, some of the threats they face and how we can monitor their health. So estuaries can be loosely defined as semi-enclosed bodies of water that have both a marine and freshwater influence. They provide a link between terrestrial and marine environments, and they are functionally important and can provide a variety of ecosystem services. And they can have high ecological value and also significant cultural, recreational and commercial worth. So estuaries around the world and in New Zealand are faced by a variety of threats, and some of these include habitat loss, sedimentation, eutrophication, which is caused by increasing nutrients, contamination, and climate change. So in order to monitor the health of estuaries in New Zealand, in 2001 Cawthron developed the Estuary Monitoring Protocol, which includes a standardised set of methodologies that can be used to monitor the current health of an estuary, as well as previous monitoring efforts within an estuary and against other estuaries. So this is the Shakespeare Bay Estuary, and it is situated at the head of Shakespeare Bay, in between Wedge and Kaipupu points, which is just west of Picton in the Queen Charlotte Sounds. And this estuary can be considered a coastal embayment, and it is mostly influenced by salt water, although there are a few small streams that also discharge a little bit of fresh water into the estuary as well. So the overall catchment is relatively small and it is largely vegetated. And this estuary is considered an ecologically significant site from one of Rob's earlier reports. And this is because it is an estuarine area and it contains seagrass beds, and it is also visited by the banded rail. And the estuary and its bay are also culturally significant for a variety of reasons, and used recreationally for boating and commercially as a logging port, which you can see up in the top right-hand corner of the photo. So the objective of this work was state of the environment monitoring of the estuary, and this was to meet some of the objectives of the Marlborough District Council Coastal Monitoring Strategy 2012. And the aim was to assess the health of the estuary using 2 point-in-time surveys, and these include a broad-scale habitat mapping and a fine-scale BENTHIC survey. So that you're not held in suspense till the end of the talk, I'm going to give you our main finding now, which was that the estuary was subject to generally minor pressures from key environmental stresses, and therefore we considered it to be in relatively good health. So I'm just going to go through how we came to this conclusion now, and I'm going to start with the habitat mapping component. So overall we mapped 5.4 hectares of intertidal estuary habitat, and most of this was unvegetated, so around 60%. And this largely comprised of firm mud sand, which you can see on the side of the photo, and also gravel habitat as well. So the rest of it was vegetated, around 40%, and of this, around 30% was seagrass. And because of the importance of this habitat, I'm just going to go into more detail about it now. So seagrass is the only flowering plant that grows in the sea, and it is found both intertidally, as in estuaries, and subtidally, so in bays where it is fully submerged. And there are many species all around the world, but in New Zealand we just have one, which is Zostra muelleri, and this can be found throughout in estuaries and bays throughout New Zealand, so all the way from Northland down to Stewart Island. So seagrass is an ecologically significant habitat, and it can play a variety of functional roles, and these include the trapping of sediments, stabilisation of the seabed, primary production, nutrient recycling, and it can provide a habitat for a wide range of animals, and can also directly provide food or indirectly through providing feeding or foraging grounds for other animals. And in terms of the provision of habitat, it can also be important in some areas as nursery habitats for fish. So seagrass can be considered an indicator of estuary health, and this is because it is sensitive to a number of environmental stresses and the symptoms that they can cause. So some examples are sedimentation and increasing nutrients, and both of these can actually work together or act together to reduce the clarity of the water, and this can in turn adversely affect the photosynthetic capabilities of the seagrass. So unfortunately around the world and in New Zealand, seagrass is declining, and we know that once it is lost, then it is potentially, well, it's very difficult to restore and potentially impossible in some cases. So if you have it, it's really good to look after it. And we do know from previous monitoring surveys that it is present in other estuaries within the Marlborough Sounds, although the relative abundance that we found in Shakespeare Bay was higher than these other estuaries. And in the report stating that Shakespeare Bay was a significant site, seagrass beds were specifically mentioned. So here's our map of seagrass within Shakespeare Bay estuary, and now I'm going to move on from seagrass, but I'll come back to it a bit later on. So another vegetated habitat within the estuary was salt marsh, and this is also ecologically significant habitat, and it can act as a filter. So if you've got runoff coming off the catchment, it has to kind of travel through the salt marsh, and that can filter out things, or filter out and trap things such as sediment, and reduce the sediment going into the estuary, and that can actually help protect the sensitive habitats within the estuary, such as the seagrass. So we also mapped a margin around the estuary, and we found that pretty much all of this was vegetated, and a lot of it was native vegetation, as you can see in this photo. But we also found some introduced species as well, such as these exotic grasses. So now I'm going to move on to the fine-scale survey. So we analysed a suite of benthic characteristics at 2 sites. So one was in an unvegetated area, and the other one we deliberately put within a seagrass bed. And this design, that's just showing our scientifically robust sampling design, which I'm not going to go into. So here's 3 of our Cawthron scientists hard at work in the seagrass site. And in terms of what we found, in the sediments we found that they were dominated by sand, and we found that mud and nitrogen levels were potentially high enough to be causing a slight stress on some benthic animals. And we found that the seagrass site had higher mud and nutrient levels, which we expected, and we found low or undetected contaminants.
Can I ask a question, Mr. Chairman?
Yes, of course.
The nitrogen levels, where would they be coming from, given there would be no fertiliser put on the land above that estuary there.
Yeah,
An assumption.
So nitrogen, I mean, it just is naturally in the catchment as well. So I suppose there's kind of I'd assume that it's coming in through the runoff. I mean, it can come in from point source discharges as well. So I suppose that would kind of require a further investigation to exactly where that was coming from. But nitrogen, it is natural as well. It just depends on how much of it.
So it wouldn't be there from the old freezing works that discharged into the...
I'm not sure, but my feeling is that it's not, but I can't say that for sure, because that was a historic impact that it was there. So we found a variety of benthic animals, and the top three are the most common animals that we found living on the sediment surface, and the bottom four are the most commonest ones that we found living within the sediment itself. And actually at the unvegetated site, we found that the most abundant animals were oligochaetes and polychaetes, which are the wormy looking animals. And in the seagrass site, we actually found that the most abundant animal was the cockle and also polychaetes. So coming back to the seagrass, there is a organism which is a slime mould of the genus Labyrinthula, and we know that this can infect seagrass and can cause what is known as the wasting disease. And we know that this wasting disease has caused large-scale seagrass dieback in other parts of the world, such as in North America and Europe. And the symptoms of this are blackened leaves, which you can see the darker coloration on the leaves there. And the other photo just shows you what Labyrinthula looks like under the microscope. So we do know that Labyrinthula is present in New Zealand, and in the 1960s we know that it did contribute to some seagrass dieback. And when we did the monitoring of the Shakespeare Bay Estuary, we did see some patches of darker coloration, so we deliberately targeted these and looked for Labyrinthula, and we did detect it. However, we don't know exactly what this means for the seagrass bed in the estuary, and we do know that's just because not that much study has been done on it in New Zealand, but we do know that Labyrinthula has been detected in healthy seagrass beds in New Zealand, so it is possible that it is potentially naturally present or just present in low abundance, and then if the seagrass becomes stressed for some other reason, then maybe it can have more of an impact. We just don't fully know at the moment. So in terms of summarising our work, we found that the estuary was in relatively good health, and this is because there were high value habitats such as seagrass and salt marsh. These were likely performing key functional roles, and we found that the estuary was currently unlikely to be threatened by sedimentation and excessive nutrients and contaminants. However, we did find that sediment, mud and nitrogen levels were high enough to potentially be causing a slight stress on some benthic animals. And also we did find the presence of some exotic plant species in the estuary surrounds as well. So our recommendations for the future are to conduct 5-yearly monitoring of the estuary as suggested in the estuary monitoring protocol. And we would also suggest, as well as this, to conduct targeted monitoring of ecological indicators such as the seagrass or environmental stresses caused by human activity. So for example, you could look at sediment deposition within the estuary in conjunction with forest harvesting activities in the catchment. We would also suggest the consideration of the incorporation of an iwi monitoring program, and this could align with iwi environmental management plans and also help support some of the objectives of the Marlborough District Council coastal monitoring strategy. And due to the relatively good health of this estuary, it could be used as a reference against which other similar estuaries within Queen Charlotte Sound could be compared against. And we would also suggest careful management of human activities occurring within the bay and catchment that could potentially increase environmental stresses. And we would suggest a particular focus on fine sediment, so mud, and also nitrogen levels. So there are a variety of people I'd like to acknowledge for their contribution to this work. And that's the end of my talk, so thank you for listening.
Thank you very much, Anna.